Okay, now let's start with question number one. In question number one, the limit is infinity. Whenever the limit is infinity, we replace it with some alphabet. Let's say I replace it with t, and then we do the integration as usual. So 2x power minus 2 integration limits 3 to t dx. Then add 1 in the power and divide it with the new power, the resulting power 3t. Then let's simplify it as usual. And after the simplification, we substitute the limits. Upper is t, the lower limit is 3. So here's the important part. We know that t is infinity, so we'll write as t approaches to infinity. So then this means this expression, this fraction, in fact, will approaches to 0. So therefore, the first expression would be 0, and the second one would be 2 over 3. So the answer is 2 over 3. Question number 2. Before we jump into question number 2, we should know what is the graph of sine x. Y is equals to sine x. In sine x graph, we know that the period of the graph is 2 pi, and the maximum point is at pi over 2, and the intercepts are at 0, 2 pi and pi, and the minimum point is at 3 pi over 2. And here in this sine x, the period is 2 pi. And if I add some coefficient, let's say if I add 3 over here, then the maximum point would be 3 and minus 3. Similarly, if I add 8, whatever the coefficient of this ratio, that would be the amplitude. And if I write k over here, then the amplitude would be k. Simple, no problem. So the k issue is resolved. Now what about 1 over 2? So 1 over 2 means now the period is not 2 pi, period is supposed to be changed. So the period of this graph is 2 pi divided by 1 over 2. So it is 4 pi. Okay, if it is 4 pi, it means that the maximum value is not at pi over 2. And the period means that this graph will complete in 4 pi duration. It means all the values at the original graph will be multiplied by 2. So the maximum value would be at pi, intercepts at 0, then 2 pi and 4 pi, and the minimum value would be at 3 pi. And as the coefficient is k, so it means that the amplitude is k. Maximum value is k, minimum value is minus k. So the coordinates of A would be 3 pi and minus k. Question number 2, B part. In the B part, we have to do two successive transformations. One is translation, the other one is reflection on our original curve. That was the curve f of x. And we have to do, first thing is reflection. Reflection in the y direction, that would be function minus 2 because it is negative in the y direction. And after this first transformation, we have to make a reflection. It means we will divide the whole expression by minus 1 so that it is being reflected in the x-axis. So it would be minus fx plus 2. So it means after the two successive transformation, f of x would becomes this. So now let's apply this on our given expression. The question was f of x equals to k times of sine 1 over 2x. So first transformation, that is negative, that is translation, 2 units negative in the y direction, the first thing done. Then we are going to multiply the whole thing with negative, so it is reflected in x-axis. So minus k times of sine 1 over 2x plus 2. So this is our new equation after two successive transformations. And then after that, we have to find the coordinates of the new point. Okay, so what was the a coordinate on the original expression on this curve? That was 3 pi minus k. But after first transformation, that is translation in the y direction, it would becomes 3 pi minus k minus 2. Then we multiply the whole expression by negative. It means reflection in the x-axis. Reflection in the x-axis means y coordinate will change, x coordinate would be the same. So the new coordinates would be 3 pi k plus 2. These are the coordinates of the new points after two transformations, that is translation and reflection. Question number 3. We are given with the derivative. So in order to find the equation of curve, we will integrate it. So y equals to 3, add 1 in the power, so 1 over 2 plus 1, 3 over 2, divide it with 3 over 2, this becomes 2 over 3, into derivative of 4x plus 5, that would be 4, 1 over 4 as we are doing integration. Let's see. Now simplify this, we will get y equals to 4x plus 5, 3 over 2 plus c. Now let's substitute this first point to find the value of c. X is 1, y is 9. So 9 equals to 4x plus 5, 3 over 2 plus c. So x is 1, x is replaced by 1, so 4 into 1 is 4. Okay, 4 plus 5 is 9, 9 square root is 3, 3 is 9, 27. Okay, so it is 27 over 2, take it to left hand side as well. So 27 over 2 is equals to c, so c is equals to, take the LCM, 18 minus, okay, minus 9 over 2. So the equation of the curve is, y equals to, 4x plus 5 raised to the power 3 over 2 minus 9. Okay, now let's substitute the other point to find the value of a. 5a, x is a, y is 5, 5 equals to, a equals to. Now substitute the point 5a, so a equals to 5 was 20 plus 5 over 2 minus 9 over 2, the power is 3 over 2, so 25 square root, 5, 5 is 21, 25, so it is 125 over 2, 9 over 2, simplify this, 125 minus 9, divided by 2, so it's 58, so a equals to 58. Question number 4. In question number 4, we have to prove an identity. So let's pick one of the sides. I'm choosing left hand side. In left hand side, we have sine theta plus cos theta whole square. So it is a square plus b square plus 2ab minus 1 over cos square theta. The sine square plus cos square is 1, so 1 minus 1 plus 2 sine theta cos theta minus 1 over cos square theta. Now this one will cancel with 1, so we are left with 2 sine theta cos square theta. We can write cos theta. This is also cancelled out, so we have the proof 2 tan theta, which is our right hand side. In the B part it is written hence solve this equation. It means we are going to use the previous part. That is the left hand side was equals to 2 tan theta. So I will have 2 tan theta 5 tan cube theta Take tan to left hand side. Tan theta will be equals to 2 minus 5 tan square theta equals to 0. Now we have factors. Once we have factors, we equate each factor to 0. So 2 minus 5 tan square theta equal to 0 as well. This second one would become tan theta equals to plus and minus 2 over 5. And tan theta, we know it is also it is 0 at 0, 180 and 360. Then we will adjust according to the range. Now for this tan theta equals to plus minus 2 over 5 square root, we have to see the quadrant. It is in all the four quadrants, 1, 2, 3 and 4. Let's find its basic angle, tan alpha. For basic angle, we will always consider the positive value. The basic angle is 32.3. Now we have the basic angle. We know that this basic angle is possible in all the four quadrants, first, second, third and fourth. The value is 32.3, 32.3, 32.3 and 32.3. So now we know the basic angle. Basic angle is in all the four quadrants. So in the first quadrant, it would be 32.3. Now we are writing the angle without considering the given range. We're just solving it for the first positive revolution. 32.3. Then we have 147.7, 180 minus basic angle. Then 180 plus basic angle. For the third quadrant, it would be 212.3. Then for the last quadrant, 327.7. Now as our range is greater than less than the negative side, so we are going to subtract from the rightmost value 360. So we have minus 32.3, and if you subtract from here, the answer will be outside the range. So in this question, only these two values fall in this range. Falls in this range. So the answer is theta equals to minus 32.3 and 32.3, just two values. Question number 5. In this question, we have to find the equation of normal. So we have to find its derivative. It means we will differentiate it. Minus 1. So let's find the derivative. So dy over dx would be the power is multiplied with the coefficient and the power is reduced by 1, and then the derivative of the bracket, or you can say the function, which is 4x. So the final answer is minus 12 over 12x, in fact, over 2x squared minus 5 squared. Now we are supposed to find the derivative at the point 2, 1. So replace x with 2. So dy over dx becomes minus 8 over 3. This is gradient of tangent. So gradient of normal would be its minus reciprocal, because tangent and normal are perpendicular to each other. Alright, now we have the gradient of normal, which is 3 over 8, and we have the point which is 2, 1. So let's find the equation. Y minus y1 mx minus x1. Substitute the values. Y minus 1, 3 over 8 x minus 2. Let's do the cross multiplication. 8y minus 8 equals to 3x minus 6. Now let's take all the things to right hand side or left hand side. I'm taking all the things to right hand side, so 3x minus 8y plus 2 equal to 0. Because it is required in the question to write the equation in this format. Question number 6. It is given that the coefficient of x cube in this expansion is 432. So let's find the coefficient of x cube. We know this is we are going to expand the power 4, not the power 1. So in this expansion, we need x power 2 and 3 so that the product would become 3. So let's work on this first factor. The formula would be 4cr 2ax r 4 minus r, and we are interested in the power 2 and 3. So we will replace r with 2 and 3 so that we get coefficient of x square and x cube. Okay, so our question would be 4c2 2 square ax 2, then 4c3, this is 3 and this is 1. After simplification, we have 24a squared x squared. Okay, now let's multiply it together so that we get the coefficient of x cube. So we will multiply 5 with this and this with x squared. So in doing so, we will get x cube. I'm taking x cube common as well. So it would become, the first factor would be minus 224 a square a cube, in fact a cube, then 40 a cube. So my coefficient of x cube is 16 a cube, and coefficient of x cube given is 432. So divide 432 by 16, we get 27, and a equals to 3. Question number 7. We have a straight line and a quadratic curve, and it's given that the line is intersecting the curve at one point. So we are going to solve them together and then apply the discriminant. So let's substitute the value of y over here. So we have 2x squared plus 3 times of x plus 5 whole square equals to k. Then simplification. That is x squared a plus b whole square, in fact. 10x 25 minus k equal to 0. So 3x squared, 2x squared, 5x squared plus 30x 75 minus k equal to 0. This is a, this b, this c, and discriminant would be equal to 0. So let's substitute the values. Equal to 0. So b is 30, 5, 75 minus k. Let's simplify. That would be 900 minus 20, 25, 1500, and then plus 20k equals 0. So 20k will be equals to 600 minus 600 plus 600. So k equals to 30. So simple. Whenever we have a line and a curve, and curve is quadratic one, we solve them simultaneously and then apply the condition, whatever it is, using the discriminant. Okay, 7b. In the 7b part, we have to find the coordinates of p. We know p exists when k is 30. So the value of k is 30, which we obtained from the previous part. And after solving these two equations simultaneously, we got 5x squared plus 30x 75 minus k. In the previous part, we are going to replace this 30 value in it. So as a result, we have an equation 35 minus k, that would be 45, equal to 0. We can take 5 common, 6x plus 9. Now it is x plus 3 whole square equals to 0. So x is equals to minus 3. This is the x coordinate of point P. Now replace it in the equation. So therefore y equals to minus 3 plus 5. Y equals to 2. So the coordinates of P are minus 3 and 2. Question number 8. A part in arithmetic sequence is such that the first term is 6, that is T1, which is also A is 6, and 10th term is 19.5. Find the sum of 100 terms. So it means we have to find S100. Okay, so now let's start with the given information. We know that Tn is equals to A plus n minus 1d. So T10 equals to A plus 9d, which is equals to 19.5. We also have the value of A, which is 6. So 6 plus 9d, 19.5. By solving this, we get d equals to 3 over 2, or 1.5. Now we have to find the sum of 100 terms. So we know the formula n over 2. So 100 over 2, 2a plus n minus 1, which is 99, 1.5. Now let's simplify this. So sum of first 100 terms is 8025. Very simple question. Okay, A to B part. In B part, we have geometric progression. The terms are 1, 2, 3, A1, A2, A3 is such that A1 is 24. Common ratio is R. It means this is the value of R. This is the value of R. And this is A1. Sum to infinity is given by S. The sum to infinity is SE. Find the value of S and okay. Now we have to find sum to infinity, and then we have to find sum of even numbers. So we know that A1 is 8. So let's apply the formula. Sum to infinity A over 1 minus R. So sum to infinity is represented by S. A is 24. 1 minus 1 over 2, which is 0.5. Solve this. So the answer is 48. Which is, so this is sum to infinity. Now we know that A1, the first term, is 24 and R is 1 over 2. So we can find the next terms as well. So A2, second term would be 24 into 1 over 2, 12. A3, 24 into 12 into 1 over 2, 6. Then A4, 3, A5, 1.5, and so on. And we are interested in the even numbers. So the even numbers would be even terms, in fact, 12. Then we have fourth term, which is 3, and so on. Then we have sixth term, 1.5 into 1.5, 2.2, and so on. The sequence will goes on. Now for this sequence, let's find the value of R. 3 over 12, 1 over 4. We have to find its even number sum. Formula is the same, A over 1 minus R. Now A is 12, 1 minus 1 over 4. Simplify this. Sum of even number 12 over 3 over 4 becomes 16. Question number 9, A part. A part. We have to find we are given with the range, find the value of k. So first of all, we have to find the value. We have to find the composite function, in fact. G f of x means g of 3x minus 2 square plus k, that will be replaced in g. So let's do that. 5 times of the function f, then minus 1. Now let's expand this to 5, 3x minus 2 whole square plus 5k minus 1. Now as it is a quadratic function, we know that the range is this part. As it is positive, so the function is minimum, the range will be greater than some particular point. So here the range will be greater than equals to 5k minus 1, and in the question it is given greater than equals to 39. So let's join these two information together. So we get 5k minus 1 equals to 39, 5k equals to 40, and k equals to 8. Now we are going to replace it in x. We will replace this value f5x minus 1 in function f. So just 3x will be replaced by 5x minus 1 minus 2, that is the whole square, and k is 8. This is the function x, this is the function f of x, and I will leave empty x value, which will be replaced by g function. That's it. Now let's simplify this. We will get 8 multiply. Now we multiply 15x minus 3 minus 2 whole square plus 8, 15x minus 5 whole square plus 8. So we can take 5 common as it is quadratic. So let's keep it in completed square form, perfect square form. So we have 25 x minus 3 whole square plus 8. Now as it again quadratic, so again use the property. So the range of this function would be greater than equals to 8. Now in 9c part, we have to find another function h such that g of h is 35x plus 19. Find an expression for g of g inverse x. So first of all, you have to find g inverse. G is 5x minus 1. Process is simple. Y equals to 5x minus 1. Interchange x with y. X equals to 5y minus 1. Make y subject again. So x plus 1 over 5. So this is our g inverse. X plus 1 over 5. Once we have the g inverse, so now let's do the remaining process. We are given with the g h of x is 35x plus 19. Let's take inverse on both sides. G inverse g h of x, g inverse 35, and this thing, this g inverse cancel out. So on the left hand side we have h of x. Substitute this value 35 plus x in g function. So as a result we get 35x plus 19. We replace this value in x of g inverse and simplify. So 35 plus 1 is 36. 35 over 5, it is 7x. 20 over 5 is 4. So h of x is 7x plus 4. Question number 10a part. We have to find the equation of tangent at some point. We have some point minus 6, 9 somewhere. I don't know where it is. Let's say the point is somewhere here. Minus 6, 9. Now we have to find equation of tangent. Let's say this is our required tangent. And point where it is intersecting is minus 6 and 9. And the corners of center is already given in the question, minus 4, 5. Let's find the gradient of radius. So y2 minus y1 over x2 minus x1, so y2 minus y1 over x2 minus x1, it is 4 over minus 2, it is minus 2. So the gradient of tangent will be 1 over 2 because tangent is perpendicular to radius. So rest of the process is same, y minus y1 m x minus x1, so y minus 9 1 over 2 x plus 6, so we have 2y minus 18 is equals to x plus 6, so finally we have 2y plus x plus 24. This is our required tangent. In the B part, we have to find the equation of the circle in this format. We have the center, we have the radius. So we know the formula. The formula is x minus a whole square, y minus b whole square is equal to radius square. Let's substitute the values. So x minus 4, so it would be x plus 4, y minus 5, root of 20 square, 20. Let's expand this. So a square plus 2ab plus b square, a square, then again 2ab plus b square equals to 20. So after simplification we have x square y square and 8x 16y, no it's 10y plus minus 16 plus 25 5 that's 21 equals to 0. This is our required equation of circle. In the C part of the same question, find the value of the theta correct to 4 significant figures. Okay. So in order to do that, we first of all have to find out the corners of A and of B. A and B are on the y-axis, which means we will substitute x0. So substitute x0. So as a result, we have equation in terms of y. Do the Milton break, or you can say you do factorization or use quadratic formula. So y is equals to 3 and 7. So it means the corners of corners of A and B are A is above, so it is 0, 7, and B is 0, 3. And we have to find this angle. So let's draw right angle triangle. The total distance is 4, so it means this much is 2. Radius is root 20. So we have a right angle triangle. In which this angle is now theta over 2. This is 20, this is 2. So let's apply the appropriate ratio, trigonometric ratio. That will be sine 2 over root of 20, theta over 2, sine inverse 2 over root 20, take its inverse and multiply by 2. 0.927295. So for significant figure, it would be 0.9273 for SF. That was the C part of question. Now for the D part, we already know the angle. The angle is 0.9273. Now we have to find the perimeter of this shaded region. So perimeter means arc length and the AB length. So perimeter would be distance between A and B is 4 plus arc length, arc AB. So 4 plus S is equals to R theta. R is root of 20, and the angle is 0.9273. Solve this, we get the perimeter 8.14. Okay, now let's find the area. Now for the area, we have to find out the area of sector minus area of triangle because it is segment. So area of sector, area means area sector minus area triangle. So area of sector is half r square theta, half r square theta, and area of triangle half r square sine of theta. So what is radius? It is root of 20, so it is 20 square means 20. Theta is 0.9273, and then sine 0.9273. Simplify it, we get 1.27 units square. Question number 11. We are given with a curve. The equation of the curve is given, and it is given that its x-intercepts are a and b, and the minimum point is m, and we are supposed to find the coordinates of m. It means the first derivative. So let's do that. So dy of dx, that would be power is multiplied with the coefficient, and the power is reduced by 1. Repeat the same process again. Power is multiplied with the coefficient, and the power is reduced by 1 plus 0. And we are going to equate it to 0 because we have to find out minimum point. Okay, so let's move one term to left hand side. This minus minus is plus to keep it to left hand side. Move the other term right hand side. So we have 4 over 3, and I'm changing the power to positive 1 over x power 4 over 3. Now move the variables to left hand side or right hand side. So 4 over 3 equals to x power 5 over 3 divided by x power 1 over 3. Use the indices properties 4 over 3. So x power 5 over 3 minus 1 over 3. That becomes 1 over 3. Now take the cube of both sides. So 4 over 3 cube x power 1 over 3 cube. So we have x equals to 64 over 27. Now we have to find the corresponding value of y. So substitute this x in the original expression and keeping that x power positive so that you can easily calculate this. Now let's simplify this. We have y equals to 18 over 16 and 9 over 4 plus 1. After simplification, taking LCM, we have this value. So the coordinates of m, which is the minimum point, is 64 over 27 x value, and the y value is minus 1 over 8. The 11b part, we have to find this area between the line segment AB and the curve. Now in order to find this area, we need the limits. Limits means x-intercepts. So put y equals 0. So the equation becomes 4 2 over 3 minus 3x power minus 1 over 3 plus 1 equal to 0. Now let's replace it with some other variable so that we have a quadratic equation. So this becomes 2a square minus 3a plus 1 equal to 0. So a equals to 1 over 2 and a equals to 1. Now replace this value back. So we have a1, a is 1 over 2 means x minus 1 over 3 is 1 over 2, and when x is minus 1 over 2 equals to 1. So x equals to 8 and x equals to 1. It means lower limit is 1 and upper limit is 8. So we will integrate the given curve. We have the limits. Now integration is simple. 2x, this is the equation above, minus 3x minus 1 over 3 dx 1 8 integration, add 1 in the power and divide it with the new power. So 1 over 3 becomes 3 minus 3x power 2 over 3 into 3 over 2 plus x, and then the limits 1 and 8. Now we replace the limits, upper limit minus lower limit. This becomes 6. So 8 1 over 3. This becomes 9 over 2. 8 power 3 over 2 plus 8 is the upper limit, and the lower limit x is 1. So 6 minus 9 over 2 plus 1. Or after simplification, the answer is 1 over 2.